Okay, so this next part of the unit that we need to learn today is about empirical formulas. An empirical formula is the smallest whole number ratio of atoms in a compound. A key thing to recognize is that an empirical formula is not what something actually is. It just simply tells us the ratio of the atoms in a compound. So for example, C2H6 is the molecular formula for a compound called ethane. Okay, this is what ethane really is. But its empirical formula is CH3 because that's what they can reduce down to. So these are the steps you're going to take when you're trying to find an empirical formula. Step 1 is you need to find the mass or the percent of each element. Step number 2 is we need to find the moles of each element. So this is like what we learned last unit, right? Where we convert from starting with grams, and then we go grams to moles. Then, after we have the moles of everything, then we need to divide the moles by the smallest number to find what our subscripts should be. And then finally, if necessary, we multiply the subscripts by a number to make sure that it's a whole number in the end. And we'll do some examples of these now.
Okay, so the goal is we want to find the empirical formula for a sample that's 25.9% nitrogen and 74.1% oxygen. So looking at your rules above, what does it say is the first thing we need?
Find the mass of each element.
We need the mass. Okay, we're given a percent, so here's the easiest way to go from a percent to a mass if we're not given any more information than this. Okay, write this down. We're going to assume that we have 100 grams of my sample.
100 grams.
What does that mean? If I have 100 grams of it, what does that mean, Philip?
That means the percents themselves are going to be the weights.
Yeah, that means the percent just turns into the grams. So I have 25.9 grams of N and 74.1 grams of O. So if you're given percent, just assume 100 so you can change them over. Okay? All right, what does the second step say we need to do? We have to convert it to moles. So let's take our grams. So 25.9 grams of N. If I'm converting to moles, grams needs to go on the bottom to cancel. Mole goes on top. What do I plug in? Good, molar mass, so that's 14.01 to every 1 mole of N. So that just came from the periodic table. Once I plug that into my calculator, I got 1.85.
You have a problem. Your GoPro is off and there's your blinky red light.
No, that means it's...
Okay.
So now we need to do the same thing for our oxygen. So what would go on the bottom this time?
Everything. Your hopes and dreams.
The molar mass of oxygen, right? In the other class, people were like translating the same number down. This is for nitrogen. This is for oxygen. So it should be 16.00 grams of O in every 1 mole. Find our answer of 4.63 moles of O. One thing I highly recommend is that you label your things because they're both moles, but you need to keep track which one is which. Okay? All right. So what we're going to do now is we take whichever one. So if you look at step 3, we need to take the smallest one and divide it by both. So since 1.85 is smaller, we're going to divide that one by itself and divide this one by 1.85, like such. So we take whichever one is the smallest, and then we divide it. So this gives us 1 mole of N, and this one ends up being 2.5 of O. So we started with grams, changed them to moles, divided by the smallest, and now we have our ratio. The problem is, if I were to write this as my formula, so it's like N1 602.5. What's wrong with that?
It's not a whole number.
It's not a whole number.
Yeah, you can't have a half of an oxygen atom. So if you end up where they're not whole numbers, we need to times it by something so that it becomes a whole number. So this one I times everything by 2, so your real answer should be N2O5. And that is the empirical formula for this compound.
Wow.
Okay, questions on that? Maybe off to the side or up by your rules, you might want to write this down. So these are the three options you'll have in this class where you have to times by something. Okay, so it's where if you have something 0.5, you always times by 2. If you have something 0.3, times by 3, because that will get you a whole number. Or you have something 0.25, you're going to times it by 4. Other than that, if you don't have these, it's either going to be a whole number or maybe really close to a whole number, right? If you got an answer of like 1.9, you can round that up to 2. But if you get an answer of 1.3, you can't round that down. You need to times it by 3 to get it to a whole number. Yeah, Austin?
So why do we have to multiply it?
Because the whole trick to an empirical formula is it's the smallest whole number ratio.
Oh.
So since this isn't a whole number, we need to make it a whole number. Good question. Yeah, Kate?
Because it's a 5, couldn't it be able to round up to?
No, because it's too far to round it. Because if you round it with that big a difference, it's actually not the right ratio. So that's why we multiply it instead. Yeah, Will?
So 0.6 and up.
It would kind of depend. For the most part, actually, if you get somewhere like 0.7, I would probably check your math again. You could get something like let's say if it was like 0.55, what would you probably just say that is? Just stay at 0.5, right? So kind of just round it. But yeah, if you did get a 0.7, most likely, there are some cases, but they're more complicated. So all the ones we're doing should work out like this, or should be really close to round. So good question though. Any other questions so far? All right, let's see how we're doing. Solve this next one for me. Solve number 6 on your paper. For me. Let's see how we're doing. Do it up here on the board. Follow along with me and make sure just what you did matches up with what I did. Okay? So we should have changed our percent to grams, which means they're just the same. Oh, thanks, Maisie. Okay, so we have 14.87 grams of phosphorus. What goes on the bottom? And where did you get that 30.97 grams? That's the molar mass of our phosphorus, okay? And that's to 1 mole, which ends up being what, 0.48? I talked to some of you about this, but one thing in particular you want to be careful with empirical formulas is because we're looking at sometimes a very slight difference in a ratio. Maintain the same number of sig figs and don't round.
Oh.
Because it actually, not always, but sometimes it actually can mess up your answer. That's sometimes where you'll get messed up and then you'll get an answer of like 1.7 and you don't know how to fix that. Okay, I think this one works out okay, but I would just make sure I would maintain at least the same number, if not add on an extra. I'm not going to be checking sig figs in the intermediate steps because it's all about just the end goal of getting the right formula. Okay? All right, this one, same thing. We take the mass, 84.13. Now we're talking about not oxygen. What are we talking about? Chlorine. 35.45
Yeah, about right.
to mole and 2.373. Okay. Keep in mind, as we keep going through this, a lot of people will be like, oh, well, here's my numbers. What do I need to times them by to get my ratio? But what do you have to do first before you times anything? We have to divide by the smallest one. So we divide by 0.48, and there's going to be one on your homework tonight where you actually have 3 different things. But the process is the same. You still just take whichever one is the smallest and divide by them all. So then we divide by 0.480 on both. This is obviously 1 mole of phosphorus. And this one ends up being like 4.95 moles of Cl, which definitely just can round up to 5. So your answer should be PCl5. Questions on that? If we didn't get it right, do we see where we messed up, hopefully?
I thought I was supposed to times by 2. Like the NU by 2.
So why don't I have to times this one by 2?
You already get 2. Because one's already, it's already 1.
Because they're already whole numbers. We only times it if these weren't whole numbers. So that's a good reminder though, because some people, because we times by 2 a lot, so a lot of times people just by default are always timesing by 2. But, okay, so now what we're going to do here is now we want to know how to find the actual molecular formula, which is really the true formula for it. Okay? And empirical is helpful, and we have to start with it, but the one that really makes something what it is the molecular formula. So to find the molecular formula, what we need to do is we need to find some sort of multiple that we times to get it what it really is. So for example, the empirical formula for ethane is CH3. Right? We saw this one in the beginning. Its actual molecular formula is C2H6. So what we have to do is we have to find what do we times this by to get it to be this. In this case, it was a multiple of 2. Right? Obviously, you don't know this because this is the goal we're trying to get to. Right? So we're trying to find out what do we need to times this by so we can get the molecular formula. So here are steps we're going to follow. Ready? Step 1 is you need the empirical formula. You can't get molecular without empirical. Step 2 is we then find the mass of our empirical formula. So we look at our empirical formula. What is the mass of that molecule? And then the third step is you're going to plug it into this equation where you divide the molecular formula mass by the empirical formula's mass. And then you get some integer. Okay, so you take the molecular formula's mass and divide it by the empirical formula's mass. This value on top is going to be given to you in the problem because that value has to be found experimentally, not mathematically. So that one's going to be given to you. This one we'll calculate on our own. Okay, then once we have our value of n, we're going to multiply the subscripts by that value. So we're going to take n and times it by our empirical formula. Okay, let's try a problem. So we want to find the empirical formula, the molecular formula for ethylene. And I know its empirical formula and I know its molar mass. So looking up above, what does step number 1 say? Find the empirical, which is already given to us. If it wasn't, we just learned how to find it. Okay, what's step 2? The mass of the empirical formula. So the empirical formula mass is we look at the formula here, and I have 1 carbon, and carbon is 12.01, plus 2 times 1.01 for hydrogen. So we're just adding up the total mass of this compound. Okay, so when we add that all up, we get 14.03 grams. So that was step 2. So that one just came from the periodic table. How do I find step 3? Or what does step 3 say we're doing?
Molecular mass.
Good, so we're going to take the molecular formula mass and divide it by the empirical formula's mass. So 14.01 on the, 3 on the bottom, 28.1 on top. So this was given. This one we found. Ends up as a 2. Empirical formula.
So that equals 2?
Not exactly.
It ends up being it's like what, 1.9?
It's going to be 2 point, right?
Or is it just
0.002.
002? Yeah, with rounding once again, because it should always be a whole number. That's actually a great point. If this wasn't a whole number, you did something wrong. Because this is never something you'll times. So that's a good way to kind of check. Okay, so then step 4, it says we're going to take our empirical formula of CH2 and times it by the number we found. So your actual molecular formula is C2H4. And that's our answer. Yeah, Austin.
So if you do the dividing part, you'll always get a whole number?
Yeah, it should be. If it's not a whole number, it would be really close to it, like 1.9 or 1.1, something like that. Because yeah, whatever we times by this should always be a whole number. So yeah, good question. Other questions? Yeah, Steph.
If you get a 1, does that mean that they're the same?
Ah, yes. If this ended up being a 1, then that means the empirical is the molecular in that case. Yeah. No, that's a great question. Comment, whatever it was. Okay, anything else right now? Okay, try the last one for me, whatever number that is. Number 8. Okay, find me the molecular formula of caffeine, everybody.
You want us today?
Love caffeine.
Okay, find me the molecular formula. So, in the end, everybody, you should have gotten 97.11 as your empirical mass, which means when you divide them, you get a value of 2, and then you times it through. So our formula, this is caffeine. Okay, everyone look up here really quick. Is this caffeine? No. Okay, C4H5N2O, that's not caffeine.
That's not caffeine.
This is caffeine. Okay, the empirical is not what it is. It's just the ratio. This is actually what caffeine is.
So why